Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Um, so today I would like to discuss with you for week number 6 integration. Actually there is no part 1 and part 2 for topic of integration because on week number 7 we discussed straight away about the technique of integration. So as a record, week number 6 we discussed only for integration. Okay. For lesson number 1, we have 3 subtopics to discuss. Number 1, indefinite integration. Second is integration of polynomials. And last but not least is finding constants in indefinite integration. Right? Okay. So it's very simple actually. The most important for integration, in other words, we use as the anti-differentiation, okay, where anti-differentiation is the reverse process to differentiation. Finding an integrals is the reverse of finding a derivative. Okay, so kalau dari segi dia punya process or the relationship between the integration and also the differentiation, both actually a reverse process. So dy over dx, okay, kalau you differentiate, okay, you akan dapat integration of a function. Okay, but if you integrate, actually you akan dapat a function to differentiate. Okay, right. So as an example, okay, we start from the basic one. What is an integral of 2x? Okay, what is an integral of 2x? And we know that the derivative of x squared is 2x. Okay, remember when you have y equal to x squared, therefore our dy over dx equal to 2x. Bring down the power minus 1. So 2 minus 1 is 1. So sebab tu you have 2x. Okay. If you reverse the process, if you integrate 2x dx, okay, therefore you will have a 2x squared over 2 plus c, or if you simplify you have x squared plus c. Okay, so you akan dapat balik the original function from function of y, right? So actually it's a reverse process. Okay, so the notation, what is the symbol for to represent as an integration? So the symbol for integrals is a stylish s, stylish s. S over there represent the word of sum, or the idea of summing slices. Okay, so we have a specific topic discussed about the idea of summing slices. It's actually the application of integration. The application of integration, actually we can identify the area under the curve. Kalau sebelum ni kita tahu, for example, just give you an idea. Let's say you have a quadratic y equal to x squared. Okay, if you differentiate, okay, you akan dapat 2x, right? 2x. Okay, y dy over dx equal to 2x. So if we integrate 2x, actually kita cuba dapatkan what is the area under this curve. Nanti kita cerita detail on the week number 9. Okay, alright, so back to this notation, the symbol. Okay, so in order, the right way to write the method of integration, you have to start with the integral symbol, kind of this stylish s, followed by 2x. 2x represent the function that we want to integrate, or we call as the integrand. Integrand. And then multiply with dx. Dx represent integrate with respect to x, or slice along x. Slices along the x. Okay. So after the integral symbol, we put the function we want to find the integral, or we call as an integrand. So this 2x we call as the integrand. Okay, and then finish with dx to make the slices go in the x direction and approach 0 in the width. Alright, so dx ni approaches 2x lah. Approaches 2x. Approaches 2x. Okay. And if you notice, we put a plus c. Right after we complete the integration, if you notice, we put as a plus c. Yang ini compulsory. Compulsory. Kalau tak ada, salah lah. Okay. So, we wrote the answer as x squared, but why plus c? Plus c over there, we call as a constant of integration. Constant of integration. Constant lah. Constant, which is from, constant ni should be integer lah. From 1 to 99. Or could be other than that lah. Could be million ke 100 ke whatsoever. Okay. As long that one we call as a constant of integration. Okay. Kenapa kena letak constant? Because this is the process. Remember when we differentiate, for example, x squared plus 4. If we differentiate, still you have 2x. Betul tak? Y equal to x squared plus 4. Differentiate, you akan dapat 2x plus 0. Kenapa plus 0 over there? Because when you differentiate constant, you have 0. Remember? Okay. So, even kalau you letak as a y equal to x squared plus 99. dy over dx, you still have 2x. Plus 0. Kenapa plus 0? Because differentiate 99. 99 is a constant. Differentiate, when we differentiate a constant, you will have a 0. So, sebab itulah, you have to put plus c, because the constant of integration is still unknown. Unless, kalau dia bagi kita extra information, or extra information given, therefore we can identify what is the unique solution for that function, ataupun what is the specific constant that include in our as our integrand. Okay, so I just explain for the first point over there. Okay, point number 2. So when we reverse the operation to find the integral, we only know 2x, but there could have been a constant of any value. So we wrap up the idea by just writing plus c at the end. I dah mention the plus c, you will have to put the plus c because it's a compulsory. Okay, compulsory. Okay, moving on. Indefinite integration. The first subtopic, indefinite integration. So we split into a few part of function. So first one, A, integrating power of x. Power of x ni not only x power of n. It could be 1 over x power of n, or it could be square root of x power of n, could be anything. Okay, but roughly we discuss only these 3 part lah. 3 type of integrating power of x. Okay, so the basic integration of x power of n is, it's very simple. You add 1 to the power, and then you divide with the new power. Okay, x power of n, your power plus 1, and then divide with the new power. This one, ini kita panggil sebagai new power. Okay, so in words, increase the power by 1, then divide by the new power. Compared to differentiation, okay, dy over dx, you will have n minus 1, right? Sorry, bring down the power and then power minus 1. Compared to integration, you add the power by 1 and then divide with the new power. Okay, and then B, multiply by constant of the power of x. Okay, what we do is, for example, you want to integrate of ax power of n dx, where your a is a multiple of x with power, ataupun constant lah. Right, so what you can do is take out the constant outside, settle for the integration of x with power. Okay, so at the end baru you multiply with the, after you complete integrate the x power of n. How to integrate x power of n? You boleh refer over here lah. Okay, so you can see at the end baru I multiply with my constant. In words, bring out the constant, then integrate the power of x. Okay, so I encourage you to use this method, which is whenever you have a multiples of x, take out the constant outside, ataupun take out the multiple outside the process of integration. At the end baru you multiply. Okay. This is the other rules of integration. Actually, I encourage you to separate the function. For example, let's say you have a addition between two functions. Let's say you have x and g function. What you can do is you boleh separate and then put the notation for both function. Contoh dia, let's say you have example, let's say you have integrate of x squared plus square root of x dx. So what you can do is you boleh separate x squared dx plus integrate square root of x dx. The main reason is because to avoid the careless mistake lah. Okay, but if you confident enough, you just proceed without splitting both function. You boleh straight away integrate. Okay, but those who still just know about this integration topic, I suggest my suggestion is to split both function, so that you boleh reduce your careless mistake. Okay, same goes to subtraction, in between two functions, separate. Okay, so let's try one exercise from this 19.01. So I choose one example, okay, from number 10. Okay, from number 10 here. So how to integrate of x over 3 plus 5 dx. So either you want to split, okay, or you blast straight away without splitting the both function. Okay, so I'm using the rules of summation just now. Okay, now, so remember when you have integration of constant ataupun multiple to your x, you boleh take out, put outside, focus on differentiate your x only. Alright, okay, now differentiate x. Over here your x is power 1, is it? Power 1, so therefore you will add 1 to your power. So therefore you will have x 1 plus 1 divided by the new power 1 plus 1. So put plus c. Okay, integrate 5. Actually over here is 5 power 0. Okay, any number power 0 is 1, is it? So 1 times 5 is 5. So sebab tu dapat 5 sini. Okay, now integrate x power 0. Remember plus 1 and divide by the new power. Also put plus c. Okay, kenapa ada plus c? Because you ada you already split your integration into two parts. So therefore you ada C1 and C2 lah technically. But don't worry about C1 plus C2 because constant still a constant, or constant subtract with constant is still a constant. So don't worry about this constant. you boleh letak at the end of your process of integration. Okay, now let's proceed over here. 1 over 3. 1 plus 1 is x power 2 divided by 2 plus 5. 0 plus 1 is 1, so x power 1 over 1 plus c. Okay, so you can see I put c plus c as a c. Constant plus constant is a constant. Right after you complete your integration process. Okay, now simplify further. Therefore, you will have x squared over 6 plus 5x plus c. Alright, so that's the answer for number 10. Okay, now number 12. A bit longer when you have a long polynomial equation. Okay, so let's do without splitting them. Okay, so straight away the first integrand, 4 plus 1 is 5 divided by the new power 5 minus 4 x. 3 plus 1 is 4 divided by the new power 4 plus x power of 3, because 2 plus 1 is 3, divided by the new powers of 4 times 3. Because you have a denominator 4, so therefore you multiply lah 4 with 3 plus, minus 4x. 1 plus 1 is 2 divided by the new power 2 plus 4x power 0, right? 0 plus 1 is 1 divided by the new power, which is 1, and don't forget to put plus c. So simplify further, you have x power of 5 divided by 5 minus x power of 4 plus x power of 3 over 12 minus 2x power of 2 plus 4x plus c. That's it. Okay, if you want to use by splitting them first, okay, and then you have a multiple of c, multiple of c, and then don't worry about the c. Again, add a c plus c, still a constant. Constant subtract constant, still a constant. Okay, moving on. Alright, question number 18. Number 18, you have to expand your bracket first. Okay, so what you can do over here, you will have x squared minus 2 minus 1 is minus 3x, and then negative 1 negative 2 is plus 2 dx. Okay, you can see I open my bracket first. Now baru I multiply with the x. So therefore you will have x cubed minus 3x squared plus 2x dx. Without splitting them, okay, I just separate by using my bracket here. So x, 3 plus 1 is 4 divided by the new power 4 minus 3x. 2 plus 1 is 3 divided by 3 plus 2x. 1 plus 1 is 2 divided by 2 divided by the new power, plus c. So simplify further, you have x power 4 over 4 minus x power of 3 plus x power of 2 plus c. Okay. Alright, moving on. Okay, at this time, some may need to be divided out first. Okay, I choose one question, number 7, from this 19.02. Okay, what you can do here is, you have to split your denominator into two parts. Okay, this is the only method, unless, for example, let's say you have a over b plus c. This is not equal to a over b plus a over c. This is totally wrong, totally wrong. You cannot even do this, alright? So remember, the only thing that you can do is when you have this kind of format, which is you are the single denominator, and then you can split. Okay, you try to prove by using the numbers over there. Okay, moving on. simplify again here. So you have 3 over x power of 3. Okay, by using rule of index. When you divide, remember power will minus. Okay. Alright. And then you have over here is 2 over x power of 2 dx. Okay, in order to solve this integration, what you can do is, number one, you have to bring up them lah. Therefore, you have a negative power. Kenapa kena bawa atas? To satisfy, remember, you ada x power of n dx. Okay, so, sebab tu kita kena bawa dia naik atas. Alright, easy for us to integrate. Okay, now integrate. Constant put outside, focus on integrate the x power of negative 3. So, negative 3 plus 1, negative 3 plus 1 is negative 2. Divide by the new power. Okay, same goes to 2 over here. Negative 2 plus 1 is negative 1. Divide by the new power. And then don't forget to put plus c. So, therefore, you will have over here is negative 3 over 2 x power of negative 2. Plus 2x power of negative 1 plus c. If you dislike this power with negative, what you can do is you boleh bring down lah. Alright, so it's going to be like this. Okay. Another question. Let's try a few questions again. So this time number 17. Okay, number 17. So again, you have to split your denominator into 2 parts. Alright. So, seems difficult, but you can change your set become power 1 over 2. Okay, now you apply the rules of index, which is when you divide 2 index with the same base, so your power will subtracted. So x 1 minus 1 over 2 dx. Okay. So therefore, I proceed over here. You akan dapat x power of 3 over 2 plus x 1 over 2 dx. Okay, kita tak start lagi integration, kita just simplify the index. Okay, now baru kita start to integrate. So 3 over 2 plus 1 is 5 over 2. Divide by the new power. 1 over 2 plus 1 is 3 over 2. Divide by the new power again. And put plus c. You might change to 2x 5 over 2 over 5 plus 2x 3 over 2 over 3 plus c. Alright, that's it. Actually boleh simplify lagi change to third, but it should be enough. Okay, moving on, number again still in exercise 19.02. Write the expression of this following integral sum may need to be divided out first. Okay, choose question number 20. Okay, number 20. Alright, now integrate number 1, you have to expand lah. Expand your bracket over there. Therefore, you have x squared plus 3 minus 2 is plus x plus, minus should be minus 6, right? Minus 6. Divided by x power of 4 dx. Okay. Again, you have to split them into 3 parts. So, x squared over x power 4, do it slowly. X divided by x power 4 minus 6 over x power 4 dx. After that, you will have integration of 1 over x power of 2 plus 1 over x power of 3 minus 6 over x power 4 dx. Okay, now you have to bring up, we are not integrate yet, plus x power negative 3 minus x power negative 4 dx. Okay, baru kita integrate ya. Alright, so x negative 2 plus 1 is negative 1 divided by the new power plus negative 3 plus 1 negative 2 divided by the new power negative 2 minus 6 negative 4 plus 1 is negative 3 over negative 3. Okay, actually kena letak plus C okay, tak apa, later kita letak. Okay, now what you have over here is negative 1 over x. I bring down the power since you have power of negative 1, so I bring down minus 1 over 2 x power of 2 minus 6 over 3. So you boleh simplify over here, negative 6 divided by negative 3, they should be plus 2, is it? So put over here plus 2 x power of 3, and then don't forget to put plus C. Okay, that's it, our second subtopic. Okay, next is evaluating the constant of integration. Now our job is to identify what is the real constant, what is the real value of our constant. Okay, so earlier we comment that the antiderivative of a function in the general is not unique. Kenapa not unique? Because remember tadi, kalau you differentiate x squared plus 4, sama je macam you differentiate x squared plus 99. Okay, not unique. Dia tak ada specific value But how to identify the constant of integration? Macam kita nak tahu what is the specific value of C that satisfy the integrand that we integrate. Okay, so what we can do is, usually they will give us a specific ataupun they give us an extra information so that kita boleh dapat the specific C constant. Okay, macam mana cara dia? Okay, from this example. So if dy over dx equal to 12x plus 4 and given that f1 equal to 2. So f1 equal to 2 is our information given lah. Okay, macam mana nak determine fx? So kita tahu yang fx ni bila kita integrate f prime x dx, is it? Or f prime x ni kita boleh dapat from we integrate f double prime, kan? Okay, so we have to integrate our function first, then substitute the value of x and y in the information given to determine the function lah. Okay, so you can see from here, in order to get the fx, so I have to integrate f prime. Okay, this is the value after I integrate my f prime. So you can see I have a plus c. So now from the information given, f1 equal to, when x equal to 2, when x equal to 1, my fx equal to 2. So therefore I substitute 1 into my x. So substitute 1 over here and 1 over here. Therefore I have 2 equal to 6 plus 4 plus c. So we can identify the c equal to negative 8. So nak buat apa dengan c equal to negative 8? Substitute back into the fx over here lah. Substitute into this function. Sebab kita nak tahu what is our unique fx. Okay, so our unique fx is 6x squared plus 4x minus 8. Okay, alright, so let's try one question from this 19.03. Okay, I've choose question E. Question E. Alright, so how to determine the fx? So to determine fx, we must to integrate our f prime. So if we integrate, you have x power 4 minus x squared over x power 6 dx. So macam nak buat? Remember, we have to split our denominator into two part. Okay, to make it more simple. Right, so therefore you have x power of 2 minus 1x power 4 dx. Okay, next bring up, easier to integrate. Okay, so therefore remember negative 2 plus 1 is negative 1 divided by negative 1 minus, okay, put bracket over here, minus x, negative 4 plus 1 is negative 3 divided by the new power, and don't forget to put plus c. Right, okay, now simplify further. You have negative 1 over x minus become plus 1 over 3x power of 3 plus c. So now we have to identify what is our c by using the information given over here. Okay, now copy the function. Just now we have negative 1 over x plus 1 over 3x power of 3 plus c. So given f1 over 2 equal to 1, which is when your x equal to half, your fx equal to 1. Okay, so therefore 1 equal to negative 1 over 1 over 2 plus 1 over 3, 1 over 2, power of 3 plus c. Simplify further. If you press your calculator, you akan dapat sini c equal to 1 over 3. Okay, so nak buat apa dengan c? Substitute back into the fx. Therefore, your fx is equal to 1 negative 1 over x plus 1 over 3x cubed plus 1 over 3. So therefore, this is the unique fx. Kalau nak check, you boleh try to differentiate. Dapat tak fx awak tu? Okay, moving on. Okay, this time kita bagi another level of finding the constant. If we start from the second derivative, we have to integrate twice to obtain the original function. Apa maksud soalan ni? Okay, katalah dia bagi kita f double prime. Okay, the process is when you integrate, you akan dapat f prime, right? And if you integrate again, you will have fx. So if they give us the second derivative, how to determine the fx? So you have to integrate twice. Ini maksud dia integrate twice. Okay, you have to integrate 2 times. Baru you boleh substitute the information given. But when you integrate twice, you akan dapat 2 constant of integration. There will be 2 constants of integration. In general, these are C1 and C2. One constant appears at each stage of integration or anti-differentiation. Dekat sini, you akan dapat C1. Kat sini pula, you akan dapat C2. It's back to basic. When you integrate constant, you akan dapat Cx. Contoh, when you integrate 4x, when you integrate 4 dx, you akan dapat 4x. Sebab kat sini actually x power 0. 0 plus 1, power dia jadi 1, is it? Divide by 1. So sebab tu you dapat 4x. Okay, so itu yang basic understanding dia. Alright, so ini ada explain. Okay, let's proceed to the question from 19.03, question number 2. Okay, I choose one question here. Okay, so given f double prime equal to divided by x cube plus 1, and also given information is over here. Okay, now in order to determine your fx, we start from finding the f prime by integrate our f double prime x. Okay, so integrate of 2 over x cube plus 1 dx. Remember, integrate you akan dapat constant, dapat C1 over here. Okay, now bring up first. Your power become negative 3 and 1 still remain as 1. Okay, now 2, bila put outside. Okay, now negative 3 plus 1 is negative 2 divided by the new power negative 2. 1, integrate 1, you have x. Okay, and then remember you akan dapat plus C1. Simplify further, negative x power negative 2 plus x plus C1. Okay, okay, now kita tak boleh lagi nak substitute with the information given because there is no f prime. Unless kalau bagi kita katalah let's say ni is f prime, then you boleh substitute the number already, so that you boleh dapat C1. You boleh identify the C1 straight away. Contoh soalan macam soalan number A. Okay, right after you differentiate once, when you integrate once, you boleh substitute already the value of your x and also your fx, f prime x. But over here they didn't give us the f prime, they give us both for fx. So kena dapatkan straight away your punya fx. So fx equal to, by integrate your f prime, alright, so integrate your f prime is over here, negative x negative 2 plus x plus c1 dx. Don't worry about the c1. C1 is only a constant. Tadi ada explain, integrate constant, you dapat constant x. Okay. Alright, so now negative x negative 2 plus 1 is negative 1 divided by the new power x squared over 2 plus C1x plus C2. Mana datang C2? Because you already integrate second time. You integrate the second time, you akan dapat another constant of integration. Simplify further, you will have x power negative 1 x squared over 2 plus C1x plus C2. Okay, now baru kita start finding the constant C1 and C2 over there. Okay, I'm going to rewrite the function. Your fx equal to x power of negative 1 plus x squared over 2 C1x plus C2. So substitute the value. F1 equal to half. So therefore, half equal to, substitute 1 plus C11 plus C2. Okay, so simplify kan, you akan dapat C1 plus C2 equal to negative 1. F2 equal to 6 1 over 2. 6 1 over 2 is 13 over 2. So therefore 13 over 2 equal to 2 negative 1. 2 squared over 2 C12 plus C2. So nanti you dapat sini ialah 2C2 plus C1 equal to 4. So let's say this is equation number 1. This is equation number 2. Seems like when you subtract equation number 2 with equation number 1, you akan dapat sini ialah 4 equal to 2C2 plus C1 minus with negative 1 equal to C1 plus C2. So 4 minus minus 1 is 5. 2 minus C1, ini minus, subtract. 2C1 minus C1. Sorry, ini C1, ini C2, Ini C1, kejap. Let me... Okay, so 2 minus 1 is C1 plus 0. C2 minus C2 is 0. Okay, now you dapat C1 equal to 5. Okay, substitute C1 equal to 5 into negative 1 equal to C1 plus C2. Negative 1 equal to 5 plus C2. So C2 equal to negative 6. Therefore, our fx is negative 1 over x. Oh, sorry, this is 1 over. This is not negative 1. This is 1 over x, right? Okay. Plus x squared over 2 plus 5x plus, sorry, minus 6. Okay. Alright. So we proceed to the lesson number 2 on the next video. Thank you.